Thank you, everyone, for alerting that. I'm sure you're looking after your friends that can attend the session today. That's really nice of you. Thank you. That's good. Okay, perfect. So let's get started here. As I said, this lecture today, we started with some technical issues, but I think we'll get going here. As I said, the database normal forms are a very essential aspect of a database design. Again, normalization, very high-level, simplistic way is try to eliminate the redundant data in the database. Okay, so as you have more and more redundant data in the database, what's going to happen is as you're trying to update, delete, the activity is going to take longer time. The processing of updates, processing of deletes will take longer time. Insertions might not be any issue there because trying to insert the data, but sometimes even when you're inserting the data, you try to check if the data is existing. So if the data is more, so even that check select statement might take longer. So in a traditional database application, which we also call as a OLTP application, like a transactional processing system. So in those systems, what we try to do is we don't want to have this extra time updating, extra time trying to delete some data, extra time to insert some data in cases of where you want to validate before you insert. So those kind of things are very essential, and also we know very well some of these online applications, we don't want to give too much weight, because if you do that, then people coming from different areas, it will give some ambiguous results, and the people might not be happy with the application, the way it is managing, and it's also going to be issues with the database. So in order to avoid all those things, any OLTP application, they try to normalize the database as much as possible. So that is basically what this article is going to talk about. And read through the article, download it. I'm not going to present here. It's a typical database course topic. So read through that. And then this flyer, I got it from an IBM, probably, I don't know, 15, 16 years old flyer. I just had it from that point, and it's really a nice document, very easy to understand. So just go through that. Okay. If you have any questions, feel free to post it on Taxila. I've tried to be up to date on Taxila, and I'm glad I've set up email alert to directly come to me whenever somebody posts something on Taxila. I am able to see those things. Sometimes I'm replying directly to the individual who are posting some message on Taxila through my email, but I also go into the Taxila and try to update periodically. Okay. So in any case, I also posted another new discussion thread on Taxila. Try to read through that. This is about big data, best practices in big data. So I know most of you are interested in that, and it's coming from Dr. Kimball group. So it's a nice article to try to go through that. If you have any feedback or any questions on it, try to post it online so we can exchange some thoughts, ideas on that. Okay. So be active in this interactive discussion so that you're also learning additional aspects, not only the topics that we cover in the class here. Okay. So if you find any such articles online, or if you come across some of those articles at work, try to post it on the discussion forums, and it is going to help other friends of yours who are taking the class. And not only that, it's going to help me. Okay. So let's make this two-way communication as much as possible. So now let's get into the topics here. So we talked about Bill Inman and Kimball in the previous lecture. So I want to make sure whoever takes this class, I want you to clearly remember these two names, because these are the we call as the gurus for a data warehouse that came into the marketplace. They introduced these concepts. So Kimball and Inman, so both of them are great researchers, and they came up with this data warehousing architectures, which we are still using, after 30, 40 years. So it's really nice, way to look at these two different architecture types. So both of them are right. Like I said in the previous lectures, I have used both architecture designs, and I have one we have implemented from ground up, is a Bill Inman's in the 2001, and even today, which is after 14 years, it still works great. Users are very happy. Data is consistent and everything is perfectly fine. So we have implemented one design, one data warehouses in Kimball in 2005, 2006 timeframe. It is still in practice, and like I said, both approaches are great. It just you need to pick and choose what is the best. And so, given me a choice, if I have a choice now, which one I would choose Kimball, because Kimball has some flexibility. In other words, he will give the Kimball's approach gives some of the results quickly to the end users. So with the marketplace that we are in 2015, nobody wants to wait for 2 years to see a data warehouse result. So things have changed. Things have changed. So it's going to be very interesting. Okay. So I still have somebody is posting they can't hear me. I'm not sure it's the case for everyone. Otherwise, I would have got a lot of messages here. Hope, Prashant, you might have to log out and come back in just like what I did, and think it's clear for everybody, so I can't help you. Probably you might have to log out and come back in. Okay, thank you. So coming back here, yes, Kimball approach is dimensional modeling. So again, the reason why I have chosen Kimball approach, even though I like Inman approach, because Inman approach is more, if you build a data warehouse in Inman approach, it is more like a traditional database. You can clearly see where the data is falling. You can understand the database, which is a third normal form you're getting from a transactional system into the data warehouse. You can understand very well where the data is moving and everything, but it is going to be it's going to take time to implement that, because we are replicating something from a transactional system, making sure everything is there in third normal form correctly before you start building some data marts and reporting and all that. So it's a great design, but it just takes time. But Kimball approach, we're not building everything like what Inman is doing, but in the Kimball approach, at least we can give the results in incremental fashion. That is one of the things that we always like, which is we try to deliver some of these designs, implement something quickly and then go back and implement the next phase and things like that. Okay, so with that, I think let's move on here. And then I have taken this slide from our textbook, I think chapter 2. So I hope you already started reading our textbook. For those of you who got it, read chapter 1, and I think by now we're starting chapter 2 concepts and some of the concepts in chapter 7. So, that's why I always tell, I want you to read the book. Don't worry about what we cover here, but at least start reading the book from the beginning as we go. And then if you come across any questions that you want me to touch point, and then you can raise a question through the Textula or raise the question here, and we can take those points. But these topics are from chapter 2, so you can go through that. Okay. So as you can see here, data warehouse, I think we also touched these points in the last lecture, the second or first lecture. A data warehouse is, again, it's the way people interpret. There are some organizations, some researchers will call data warehouses, even if you have a single data mart, it's a data warehouse. Okay, and some people, I also said, even if it doesn't have any of the concepts of data mart, it is very big in nature and it does support reporting, they call that as a data warehouse. So it is just a terminology people exchange based on their comfort level, based on their usage in their organization. So again, a data warehouse is a corporate wide. It's kind of you're addressing for entire organization. A data mart is kind of a departmental or a process oriented. So you're kind of focusing in one process, and then you're delivering and reporting in that process area or in that department. Okay, so here again, a data warehouse is a combination of multiple data marts, and in case of data mart, you have a single business process. That's basically focused, because we don't want to mix up business process concepts into one data mart. If I think I touched this point very clearly last lecture also. We don't want to mix up sales with the claims. We don't want to mix up sales with the bank accounts. bank savings details, or let's say if it's a banking industry, I don't want to mix with savings accounts or deposit accounts with the loan accounts. If they are trying to do the analysis differently, if there are different departments managing loan department and you have a different department managing savings, CDs and checking accounts, then you better segregate those things, and based on those needs, you try to build the data marts. Okay. So we talk about star schema, star joins as we go in the next few slides here, today or tomorrow. And then we talk about queries and presentation source, because here in this case, if you see here in a data warehouse, also you'll have multiple star schemas, multiple data marts, and then you'll have different queries and reporting on top of this data warehouse. Okay, and the data warehouse will give a corporate-wide view. It's kind of very high-level view about entire organization, and a data mart will give a view within the organization for a specific department. Okay, so again, like I said, the data warehouse, is organized on ER model if we are talking about Inman approach, and here the data mart is organized, structured based on the departmental data. So again, if I correlate these concepts, if I go back to the Inman and Kimmel approach, so we can say that top-down approach is the Inman approach. Okay, we're getting the top-down approach, so that means Inman is a top-down approach. That means you're trying to build, for entire organization. That is the reason why it is going to take a longer time. And you're also building on a normalized data model. So you're trying to build a normalized data model, and then on top of it, you're going to build the denormalized star schemas and things like that. So again, like I said, enterprise-wide data, central storage, you'll have everything is in one place, and then you try to build. It takes longer time to build because you're trying to first build a normalized model and then trying to build a star schema on top of it. So it is going to take a longer time, but it is a very structured, clearly laid out plan so that everybody can understand that has a database knowledge. So it's very clearly laid out plan. So it's again a choice which one you want to take. So there is a high exposure to risk and failure because it's very long. It takes a long time because it takes 2 to 3 years, some cases, if it is a very big organization. So you need to have strong support from the management. You need to have funds available with these economic situations. Having for 2 years for millions of dollars reserved for data warehousing is going to be a challenge. It's very challenging aspect, especially the current economic situations. But again, the Kimmel approach is a denormalized data model. You start right from there. You don't try to build a normalized model, but you try to start thinking in a denormalized model so that your goal is completely different. So here you're trying to try to reuse some of the aspects as much as possible. And I say conformed. Conformed means I would like to share some of the business objects. For example, let us say I'm an organization and I have a banking industry. I'm working in a banking industry. So if I'm working in a banking industry, I have different business processes where I might have a loans department, I might have a savings department, or I might have home loan departments, I might have a commercial loan department. So when I see these different areas, or I might have retirement savings department, in these things, even though different business processes are there, I have a customer. Let us say Anshu and Anurag, they are customers in this bank, and Anshu might have a loan for a house. Anurag might have a savings account, and Anshu also might have a savings account. So same customer is falling into different business processes depending on the products they try to use. So customer is one of the components that could be shared across these different data marts, because it's very clear, a customer can cross over different business processes. Employees within the organization, they are focused on, for example, savings, and there could be some other employees focused only on loans. There could be some other employees focused only on retirement accounts, but the customer itself, an entity, it could be crossover because some customers within the entity could be having savings accounts, loan accounts, and retirement accounts. Some customers might only have savings accounts. So, these kind of things, when you see clearly, that means you can share these components. You don't have to build the customer in 3 different times when you have 3 different data marts. So that's what they call as conform. That means you're going to share some of these common objects across multiple data marts. Okay, so inherently incremental. Again, you can see here it's an incrementally building the data marts. So we're going to build the data mart over data mart over data mart. So we're not going to build the entire data warehouse at one time. So it is less risk. So as soon as you build one data mart which has a customer, let us say you're building another data mart after 6 months, 1 year down the road. Now we already see what kind of components I can reuse in this data mart, like a customer, a vendor, or some other promotion, whatever it is. This kind of things, if I want to reuse, I don't have to rebuild those things because I already there. I can just use in the next data mart and then build the data mart, whatever new additional components or additional objects that I need. So it is incremental. It's it's going to be flexible in such a way that if I want to change something, I can also go back and change because you're not waiting too long. You're already giving some results to the user in a short period of time, so that you have some flexibility to go back and redesign a little bit or tweak some of the design aspects that you already thought through for one of the phases. Okay, so it's a less risk. So again, as I said, this is a top-down approach. Again, we're talking from a high-level point all the way going down to build this. But in case of bottom-up approach, Kimball approach, you start from denormalized model, slowly build a data mart, a star schema. Okay, so you're not building a third normal form or entire thing very high level and then coming down to the data warehouse. Here, day one, you start about, okay, what are the business processes? So what are the different objects that I can share? What are the different objects that is going to comprise in this data mart? So how am I going to use this data mart for reporting purpose, analysis purpose, analytics purpose, whatever it is? So your thought process is different. Of course, you're going to also ask the same questions here, but here your approach is you're first building the data warehouse like in the third normal form. So it's one of the things is okay, bring everything into your data warehouse from operational system, whatever you need for reporting, and then start building the data marts. Okay. So so let me take a couple of questions here before we move on. Okay. So what is the dimensional model? Okay, Kimball. Okay, that's right, Bitesh, you're right. It is a Kimball approach. Dimensional model we're going to cover in detail as we go in this lecture or next lecture. Denormalize the whole TP database where it come. Okay, that's right, Andrew. You're right because, like I said, a data warehouse is, we're going to introduce some concept called denormalization. So in case of operational OLTP applications, we focus on more normalization. In case of top-down approach also, we are not inventing anything new normalization. We're trying to take operational system which is already normalized, you're going to bring it here. So most of the operational systems are in third normal form. You just bring it into the data warehouse in a third normal form. So you're not thinking more on that aspect. It's just already there. You just put it there. So probably we tweak a little bit here and there. But after that, we try to denormalize so that you can start building a data mart or a star schema on top of it so that we can deliver some reporting and analytics. Okay, that's basically what top-down approach, and I think that's. Hope it is clear for you, Andrew. There, that's basically what I was trying to explain. So if you take a database class, you more focus on normalization. They never talk about denormalization. But when you take a data warehouse class, we touch normalization, but we try to introduce a new concept called denormalize because most of the databases in a real life are normalized. So when it comes to the data warehouse, we would like to denormalize because I think a couple of slides in the previous lecture clearly explained if I have data duplicated, okay, the descriptions and those kind of things are some pre-calculated values. I don't have to go and join multiple tables. If I don't have that, that means I have to go and find different tables and fetch the data, which will take time because again, when I'm going to different tables, they are in the disk. That will be sometimes the two tables that I'm looking try to join. They might be in the same disk or they might be in two different disk packs. So that means I have some I/O time, input output time, to go and grab the data from the disk to come into the memory and then join and then present to the user. So it is a time-consuming process. So to avoid those things, in the reporting side, in the data warehouse, what we try to do is we denormalize. That means we try to introduce some redundant data into the table so that it's easy for us to grab it. Okay, so I think that is clear there. Third normal form, yes, that's right. Facts and dimensions, can you explain, Anju? Yes, we're coming to that point in the next couple of slides here, so we will deep dive on that either today or tomorrow. Okay, we're not getting the audio, video. I can't help you there. Probably it's local to you because I have 100 students here and I think things are going fine as you see. That's good. Top-down means first data warehouse will be designed and then come to the data marts. Yes, that's right. You start building entire data warehouse. That means bring everything that you need, all the data that you need into the data warehouse, and then start building a star schema on top of it. Okay, that's basically what I meant to say. Okay. Okay, that's good. We covered that point. Okay. So both give the enterprise view, is it? Yes, Chetan, you're right. Both of them will give enterprise view, but if you look at the Kimball approach, you will still get the enterprise view in 2 years down the road. I agree. But you start with one departmental view, then you add another department, you add another department. By the time 2 years comes, probably you will have all the departments in the organization. Then you will get enterprise view, enterprise-wide view in the data warehouse. Whereas in Kimball approach, you start with enterprise-wide view is your design focus, and then you bring everything in the data warehouse and then start building their star schemas and all those on top of it. So at the end of the day, if you want to see enterprise-wide view, it means all the business process and everything, both might take same amount of time. That is the reason why I said in the beginning, for me, both approaches are same. Again, given the time, given the dynamics of how the business is going today, I would say I'm going to lean towards Kimball approach. Again, it's not that I'm partial there or anything like that. Again, the dynamics that are playing in the marketplace today, the financial situation, and everybody wants quick. They don't want to wait too long. So, with that aspect, I'm leaning towards Kimball. Otherwise, I prefer Inman approach because if I'm working on a traditional database OLTP system for 10 years, now I'm building a data warehouse. It's easy for me to transform my career from this to data warehouse because I'm seeing the same flow at least to some extent, and then I'm adding some new concepts. At least when I'm moving to this field, I can see, oh, everything I see here is pretty much same like what I have seen before. It just gives some comfort level. That's all I'm telling. Okay, so it's again a view that you can elaborate that. Okay, what if the source is already in third normal form? Which approach should we go for? Abhitesh, you're right. Again, like I said, most of the source systems are in third normal form, majority of them. Okay, some of them might have gone to fourth normal form, but majority of them will stop at third normal form. So it is very common. So you take from that, and even if you go to Kimball approach, it just gives you comfort level because if it's already third normal form, you pick and choose whatever you need, try to build either Kimball approach or Inman approach. It doesn't matter from here to point. What is the risk in the top-down approach? The risk here, as I said, high risk is basically, having the management support for a longer period, and then, let us say you have designed, thought through everything now, and by the time the results come, it will be 2 years down the road. And what is the guarantee that the people that you talk through today will be there after 2 years? That means the people who made the decisions on the business requirements and everything will be there after a year and a half or 2 years. And those people, even if they are there, what is the guarantee that they will agree to what they told today? Because people keep changing, the businesses keep changing. So there is a lot of dynamics that is going to play. That is basically what I said, risk. Hopefully you got the point there, Abhitesh there. Okay, so Okay, so we talked about top-down. Can we say we can use Inman approach for the data mart and Kimball for the enterprise-wide view? Like I said, it's a choice. We can pick and choose whatever we like, but like I said, we have to go with the situation that we are. Okay. So top-down approach will have a lower performance. No, okay. Don't, Kavita, I'm not going to talk about performance here. We have a lot of time. Both approaches will have, the goal of a data warehouse architect is we want to give as efficient data warehouse design as much possible, so that people, when they try to come to the data warehouse, try to run the reports, they will run quick. Again, when I say quick, it could be 1 minute, 2 minutes, sometimes 5 minutes. Still, 5 minutes is quick for me, because if I'm going through 3 years worth of data and trying to analyze and then present it to the user, so the user will be very happy. So it all depends on the volume of data you're crunching to produce the results. So performance is not an issue. Both approaches will give same performance or better performance on one over the other. It all depends how better you design the architecture. But again, in my view, even if it's not performing, your task is to make it perform better. So as a data warehouse architect, okay. So that's how I look at it. Normalization and denormalization. Can you please clear my doubt? Okay, Manpreet. Again, very simple terms. Normalization in a database is eliminate the redundant data. Denormalization, introducing some redundant data. Okay, we talk about those points in more details. Very simple, very high level. Normalization, remove the redundancy. Denormalization, add redundant data into the database. That's a simple way I can explain there. So you can post your question on TextLearn, and some of your friends will give some examples probably. Give any example where we can use top-down, bottom-up approach. Again, Naman Gupta, I think I just explained to you. We have personally built a top-down approach 2001. It took almost a year and a half to build the data warehouse, and it is working great performance-wise, consistency, data consistency, everything is user adaptability, everything is perfectly fine. We also built a Kimball approach in 2005, 2006. It is also doing the same level like what we had in the Inman approach. So it's a choice that you can take what works best for the organization and how things will play. Okay, both will give the results that you need for data warehouse. How do we take a decision on which approach to go? Is it dependent on the complexity of the OLTP design? No, again, it doesn't matter what complexity you have the OLTP design, because you need to extract the data that you need for your reporting. You need to bring the data into your data warehouse. It doesn't matter how complexity it is. You will work with the OLTP application teams. So there will be a different team who is managing OLTP applications. They will have the knowledge about the OLTP application. You are only going to go and ask them, based on your discussions with your business leaders, what kind of reporting they need, and then based on the data that they need in the reporting, you go to the OLTP and say, look, this is all the data objects my business is looking in my reporting and how I can get it. So they are the ones who are going to design the extract programs and give it to you. So it doesn't matter how complex the OLTP application is or how OLTP database is, you're going to work with them and get the data that you need into the data warehouse. Is data mart and data warehouse not similar in design or architecture perspective? Again, like I said, it's a terminology that we like to use. A data warehouse is nothing but a data mart. Okay, so I don't, if I have even a single data mart, I can call it a data warehouse. Okay, so it's just a terminology that people like to use depending on the situation that they are in. Okay. As you give an example of a department, Kimball will be better into that, right? Because suppose today I have 2 departments and tomorrow I will have 4 more. Yes, that's what I said just 3 minutes ago, Janish. I think you can start with 1, and also the Kimball approach is, like I said, when you build one departmental view of a data mart and you have different objects within that, and then when you're building second one, you're going to think through, go back and see what are the objects I can reuse. I think if you have taken object-oriented class, I don't know what is the concept that you have in object-oriented. It's a long time I took a class. It's reusability. Okay, so there's a terminology that they use in object-oriented programming. Reusability is a big thing there. You build an object, try to reuse. Okay, so there is a specific terminology I don't remember, but for sure the same concept here. You're trying to reuse some of the objects that you already built when you go to the next data mart. So it's just an advantage that you have. So it's just a choice again. Subset of similar to a data warehouse. Yes, Rajeshwari, you're right. A data mart. Again, data warehouse could be multiple data marts. So it's a subset. One of the data mart is a subset of 4 data marts. So your view is right. Right. In both the cases, storage required will be the same. Okay, that's an interesting question, Rajeshwari. Okay, so that I cannot answer exactly because the storage is another aspect, that we will touch as part of the second half of the course. It depends. Again, in my view, with my experience in the data warehouse field, when I go and ask my storage team, I always ask if I need some space. I don't go and ask, can you give 1 gig, 2 gig, something like that. Every time I go and ask my team, just add 100 gigabytes of space to this storage, or 200 gigabytes of storage to this. So we know we're going to play with a lot of data, a lot of storage. So I'm really not that much into it, but for sure, when the situation comes, we're going to pay attention where we want to cut it, because there is always a need where you need to keep more storage in the data warehouse, so that in cases of sudden growth and things like that, you're not going to crash and things will go smoothly. So again, we're going to touch that point as part of second half, but very high level, they both might take similar storage space, not much different there. In case of Inment, probably a little extra because you're replicating everything, but it's again, we'll have to see how that goes. Yes, that's right. Due to joins of different tables, it will add more time, that's for sure. Why it takes 2 to 3 years to build a data warehouse on the ROG? That's a good question. The design process itself might take 2-3 months. Very simple. Talking to the business, what they need, whatever the things, and then once you understand the design, 2-3 months. I'm using the Inman approach. So it takes 2-3 months to build the design, and then you start working with the operational systems, OLTP systems. Ask them to build these extract programs that you need the data out of the operational system. That might take 2-3 months, and of course you can do some parallel activity as they're doing extracts in the data warehouse. You might do some design aspects and everything, but I'm just giving you 2-3 months of design, 2-3 months for extraction, 2-3 months for your data warehouse design aspects, building everything, and then after that you're going to bring the data into the data warehouse and then process through it. It just adds the time. So then on top of it you build the reporting. So it's a long process for sure. At least in the Inman approach it will take at least a year and a half, not 2 years. Okay. Vipul, you're right. Like I said, the incrementally built, which is another terminology that you call is agile methodology. Yes, we can call that as an agile methodology at a very high level. Okay, so it's not going to be true agile because true agility means you have very short increments. You keep refreshing based on the feedback and things like that. But we're not going to go to that many increments here. But at least very high level, it is an agile methodology. Okay, if redundancy increase means simultaneously storage also increase proportionally, so it doesn't affect the costing. Janardhan, you're right. Janardhan, that's good. Jonathan is an American name here, and Janardhan, that's good. At least, I'm sorry, I misspoke you, but I have a colleague here, Jonathan, so it just immediately came that name. Anyway, you're right. For sure the storage will increase. There's no question about it. Like I said, we have one table in my data warehouse which is 500 gigabytes. So you can imagine, how much data it is in that table. So some of the operational databases, operational database applications of 100 gigabytes. I have one table with 500 gigabytes, so it just adds up because we are storing historical data and some redundant data and all that. Which approach is widely adopted by organizations? Kiritiga, that's a good question, very generic question. It's just going to be a challenging question to answer for sure. Like I said, in our organization I can speak to, we have 50%. We have 2 data warehouses in the Kimball approach and 3 Two of them in an Inman approach, and one of them is kind of very old legacy data warehouse. Okay, so I would say 50-50. So that's very high level again. What do you mean by conformed data model? Again, like I said, conformed in the sense, like I already explained this, conformed means you're trying to reuse the objects. We're going to touch in detail as we go, Bindu, so just stay on that question for a while. Denormalizing data will increase data duplicacy. Okay, we talked about that. What are the top popular solutions available today to use these two approaches? Ambarish, I think popular solutions, again, I can't answer you straight for that question, but both approaches are great, and depending on the organization, you pick and choose which works best. Restricted to relational database, yes, both of them are relational. Again, underlying database aspect, Raj Kamal, you're right. Like I said, all the data warehouses that I have seen until today, we have built on a relational databases. So again, that is my experience. So I think most of the data warehouses also are in relational. Okay. Okay, let me take a quick break on the recording here, then we go back. Okay, so want tool another time to query the table which is a 500 gig, Rajeshwari, good point. Does it take a longer time to query the data in the table that is to 500 gigabytes? Obviously, right. That is a challenging task that we're going to address in the data warehousing design. We know that some of the tables are very large, and we know that people try to extract the data out of it. So when those things happen, our goal is to design something in such a way that the performance is still not an issue. Okay, so that's the point. And again, some of the times, you will have a performance issue. In other words, there is a query that is taking 5 minutes, which means you need to be strong to explain to the business user why it is taking 5 minutes. You can't force yourself saying, okay, I'm going to bring it down to 1 minute, bring it down to 5 seconds. It is not achievable, whatever it is. So you need to accept that. Okay, so that's a very good point. Okay, some of the performance, in other words, let us say a query that is taking 5 minutes. For some of you also in this call that you're watching me, and you might argue with me, 5 minutes, that's too long. I can't wait for this result. I don't need this result because it's too long. But you need to have a confidence. You need to explain to the user that says that words and saying, look, we are having a table that is 500 gigabytes, and this is table that is storing 6 years worth of data, lot of details that we have in there, and you're asking to pull out of the 6 years worth of data. You're trying to analyze, comparing this month with last year month, comparing with this quarter with last quarter. I need to extract this data into memory and then compare and provide the results to you. This is the amount of time it takes. That is why it is taking 5 minutes. So you need to be very clear upfront, and you will have support from the business. And I'm telling you, in the last 10 years, I have worked in the data warehouses. I had a lot of people complaining about this point, and I had one of the directors. She said, "PC, I'm sorry, I don't want this data warehouse. It is taking 5 minutes." So I had to go back to her and explain to her that the same query that was the same amount of data, the same type of data that users wanted to get in SAP system, they could not even get, even if they run for half an hour. And most of the time, the reports that they try to run the same exact data in SAP system, it was failing. So when I took that example and took it to her and explained to her, look, this is the same data set. I'm giving the data to you in 5 to 7 minutes. Go to SAP, you don't even get the results. So what do you think she will say? So she will accept it. So that is how you need to come up with some examples when you have those kind of performance issues, Rajeshwari. And it's a reality. It's reality. You're working with a lot of data, and there are some situations where you try every effort to bring down the performance, to improve the performance, but there is a limit. And once you reach that limit, you need to explain politely and with examples and make people understand. Once they understand, There is no issue. And like I said, there is one data warehouse we built an in-memory approach. It is there for last 15 years. And I have seen some of the reports that are run in that using my logs. There are some reports that run 7 minutes, some of them reports run 8 minutes. And you won't believe, even today after 15 years, I have never received even a single complaint from the data warehouse. So what does that mean? You educate your business users. You educate your users that are using your data warehouse. Clearly explain right from the day one. Okay? Don't overcommit yourself. If you overcommit yourself, that means you are killing yourself. Okay? Then data warehouse is not your choice. And you got to be very clear, because there's a point that I have seen many situations. Some of the managers in the data warehousing field I have seen, and probably some of you might have experienced to this one. Okay, a manager who doesn't know the technology and he is managing a data warehouse, and then there is a user like what I gave an example. A director comes to him and say, I'm sorry, this data warehouse is not good. It is taking 7 minutes. My tolerance limit for any reporting is 3 minutes. So what is that manager will do? Come to the team and say, guys, whatever you do, I want the results. The management, the business doesn't like this performance. How do you improve it? So without thinking, if you go and put those targets to your team in the data warehouse team, it's going to be challenging. People will be working night and day, but you cannot achieve it. So it's just sometimes technical solutions are not the only solutions you have in the data warehouse. You also need to play some tricks and give some examples, find reasonable explanations so that it makes sense logically. Okay, again, that's what I said right in the day one in the lecture one. Data warehousing or database is mostly a common sense. Okay, we need to play that. Otherwise, you struggle yourself. You will not be a happy camper in the data warehousing field. Again, I'm telling you, 15 years, I've worked in different data warehousing fields. I have never stressed out. I was always, you know what you're working with. Be clear and explain the same thing to you. I'm sure there are some frustrations, but you just have to take those frustrations out and then come up with some reasonable results. I think, Rajesh, I hope you got my point there, and we'll come to the point as more detail as possible in the second half of the lecture. Cost impact, let's not touch that right now. We have a lot of time to go on that one. Does it take more space? Okay, we talked about that, Bibin. I think denormalization, normalization. Again, space is not an issue for me. Like I said, we have 2 terabytes. Adding another 100 gig out of 2 terabytes is not an issue. We will manage that. Last question, denormalized data mode. We'll have repeated data. How it will handle the change in the data? Do you think there will be possible to more errors? Again, like I said, changes will happen in the back end. That means the changes will happen in nightly processing, not during day-to-day process, like during the daily transaction. So, yes, there will be some changes, but again, we'll address those points as we go. Data warehouse design, data modeling, yes, you're right. We will touch that data modeling aspects as we go. Okay, we talked about the best. Okay, that's good. Vinayak, yes, we are going to touch about partitions and all of those in the second half of the course to address the performance. Yes, we will touch those things. So there's a big question here. Gaurav is asking, just wanted to know what all sort of technologies are used in data warehouse today, data operations. Okay, we're going to touch all these points in the next few lectures here, okay? It's too early for those. We'll get to that point. We have been working on same situation right now with a huge data warehouse database. Others, excellent. Post your situation on Taxila. Explain that situation to all of your friends. What is the situation? Let us see what solutions people will recommend. Some of your friends will recommend, and use this forum as much as possible. I knew there are a lot of situations like that. Present those things, and I'm there to comment my experience there, and we will see what we can help you there, others. Okay, good. Parameters in decision making to choose Kimball or Inman. We've been again, I'm telling you, don't spend too much time which approach is best, which approach is not right. You just understand both concepts and try to use whatever works best for your situation. So don't parameterize. Okay, I want to use this in this situation. I want to use this in this situation. Let's not go in that route. Okay. Um, BI tools. Yes, we're going to touch those topics, Suresh. It's coming in the next slides. Next slides. Cost impact, like I said, we will touch as we go. It's not right now. We're going to deep dive those topics as we go. So it will help to avoid running the reports on regular basis. Suresh, I'm sorry, I couldn't understand your question there. Swapnil. Okay, good. I have a colleague of mine working right now in my office. Swapnil, that's a good name. Can we take question on the end of the lecture? Okay. Swapnil, I understand your point. Like I said, I would like to challenge from all of your colleagues, all of your friends here. Don't worry, we will cover the topics. I understand your concern that we're spending a lot of time on the questions, but this is the beauty of this lecture, okay? There is a lot of information in the textbook. Go through the book and the material that we have here, and we will cover all the points. So I will take the questions as we go, because that is how I would like to do it. And feel free, if somebody wants to start, please open the discussion. I would like to have those discussions. Okay. I would like to give another example for you. Sometimes my lectures are not in the presentations, discussions. That is how I would like to do it, Swapnil. I'm sorry that you are telling me to jump to the end for the questions. I would like to answer the question when the student has the question. Sometimes the thought will go away and then it's not going to work. Okay, don't worry, we will cover the topics. So I understand your point there. I'm not discounting your suggestion, but we'll go as we go. Okay, I think bottom approach, we talked about those things. Okay, that's good. Okay, and that's the last question anyway. So no, okay, so we're continuing here. It's good. Okay, so I think that's good. So far I think we have covered a lot of points. I think it's a good topic. I want to be very clear on these points so that it's interesting, so that we can move on here. Okay, now we're touching about data warehouse architecture types. Okay, so these are the architecture types so that I would like to highlight. There are 4 or 5 slides on this. There are different architecture types. These are coming straight from our textbook. So I think chapter 2, you can read through that and you should be able to get through those points. So one of the architecture type here you can see here is a centralized data warehouse. So as you can see here, the data is coming from a source system, which is a OLTP system. It is coming to the staging area, which is the entry point to any data warehouse. Again, when I'm highlighting these points, try to understand these are the important concepts. I have seen people bypassing the staging area thinking, oh, this is waste of time. This is waste of space. There's a lot of arguments you can do, but in a data warehouse, I would like to follow a process. Data coming from a source system lands into the staging area. It doesn't matter how small the table is, how simple the data is. Okay, irrespective, it will land into the staging area. Only then it will go into my data warehouse area. Again, this is the data warehouse area for this. Again, in this case, very simple data warehouse. As you can see here, data comes into staging and you have the data warehouse tables here. Here we're not talking about data marts, not talking about anything. So you have a data warehouse and then you have reports and queries. So this is an example I said way in the beginning. There could be a data warehouse, very large database, that is like a data warehouse. You don't have a star schema, nothing like that, but you still have data reporting and the analytics on the database. So we can consider this as a data warehouse here, because again there are different ways people look at it, data warehouse aspect, because as you can see here, so you have visibility clearly here in this case. So you have a source system where operational data is happening every day, and you have a reporting system here, data coming into the staging, and then you're putting into the data warehouse, which is a data storage organization or operational data store, ODS. So okay, so this is again a table or big tables, group of tables, whatever it is, database. And in this case, so what you're trying to do here is this operational system, OLTP system, you have data in and out. Whereas in this case, data is coming only in, and then the reports are the only ones that are taking the data out. So there is no user going to update this database. So it's again, you see here, even though we are not introducing Kimball approach, we have not used Inman approach, but it is this kind of data warehouse concept where data warehouse is kind of a database that doesn't get changed by user directly, and data warehouse is a database that takes the data from operational system and it is used for reporting. If we take this simple terminology like this, a database is a data warehouse if it is serving reporting analytics and it is getting the data from an operational system and no user is directly updating the database. So these are some of the concepts, very high level. As long as you see that kind of things, you can say it's a data warehouse. And I have seen those things. So, don't put your Kimball approach, then only it's a data warehouse. If it is in so you need to be a little bit broader as by broad. It's coming back. Okay, so we have back again. So let's see. Hope it'll stay. I'll wait for a few seconds here. Hopefully it will refresh. Okay, so I think it will come back. I think I have seen get your voice in the meeting. I left the session. Okay, not able to get any voice in the meeting. Okay, let's see if you can hear me well now. Okay, it's okay. I think that's good. Thank you. Perfect. Okay, so like I said, this example here is the one I talked in the last couple of lectures. Also, we talked about a few minutes ago. A data warehouse is this simple is also considered data warehouse. Okay, so that's how I would like to say. The next architecture you can see here. This is like the data source system is coming here again. OLTP system. It's coming to the data staging. Staging area where all the data is going to come in. And then from here, it's going to go to different data marts. There is an independent data mart here. There's another data mart here, another data mart here. And then you have reports on these data marts. Okay. So it is an interesting concept here. You have multiple data marts compared to here. You have staging, and then it will build the data marts independent ones. So you're not kind of concept of sharing is not in this picture here. It's independent data marts. Okay, each data mart in this model serves a particular business unit, particular area of organization. Okay, so they're independent. They're not sharing anything. It's just independent. Sometimes this is easy to build, easy to work with. So there is no dependency in the sense. Let us say there is a one department data warehouse. If there is a problem to them, it is only a problem for them. Other data marts within the same organization, other data marts will work fine without any problem. Okay, so if there is a problem in this data mart, so other two business units don't have to worry about what's going on. Everything will work fine because their data marts are having no issues. So this is one of the benefits you have, but at the same time, there's a lot of disadvantages because you're losing the shareability, the reusability concepts, and also space could be another issue. Storage could be the cost will be another issue. So there's a lot of other issues. Only advantage here is you're giving independency to a given department. That's all it is. So again, it's one of the data marts designs that you might come across if you go on different organizations. Okay, staging is a area, and again, staging is a part of your data warehouse. It's a bunch of tables where any data that comes from a source system, it will first land in those tables, and then it will go to the next level. Okay, it's kind of a database table. Okay, where you hold the data. Okay, so that's basically what it is. Okay. The next kind of architecture here in this case is, as you can see, you have a source data and you have a data staging. Like I said again, so it is again an Inman approach here where you're building from a data staging into a data storage, which is again a third normal form database. And from here, you're building the different data marts for different business units or business processes. The key difference here, you can see here, this is a third normal form, and this is a bunch of tables, database tables in the staging. There is no relationships or nothing like that. The only relationship at the staging area is there will be one-to-one relationship for your interface program that you build. An interface program is the one that extracts the data from the source and inserts into your staging area. There's an interface that you build for extractions and transformations and loading. So these are the only programs connected from the source to the target areas here in the staging. So there is no other relationships within that. There's a very minor relationship, if at all, if any, but mostly there are one-to-one relationship with the interface. And after that, the data will go into this, depending on your third normal form, depending on which tables it has to go, it will go and update it. And then you're going to build these different data marts. Okay, so these are the different data marts, independent data marts that you have built on top of this third normal form. So here, when the data comes here, in this case, you have a data is not denormalized. Okay, and then you can see here the difference here also. There is the reports and queries. There are some reports and queries they run directly on the third normal form tables. There are some reports and queries that come directly from data mart. And obviously, there is a question that Rajeshwari asked a few minutes ago. If the query coming from this storage, obviously it is going to take time. So that is the reason why when you are building the reports and queries, you are very carefully designed in such a way that majority of them come from these data marts. Very few reports come from here, and there are very less number of users are using this path. Okay, so that is how you need to be designed in such a way that you don't give 90% of users using this, 10% of users using this. Your design should be in such a way that only 5 to 10% of users flowing through this path, 80 to 90% of users flowing through this path. Okay, so again, data storage is nothing but again it's like a database tables. Okay, that's basically what it is. Data staging is also nothing but database tables. So we're just using this different terminology. That's all it is. Okay, again, this is Inman approach. So we talked about Inman and Kimball approach. So we're just looking at another architecture type here. So if we come back to this, the hub and spoke model here, which is a Kimball approach. As you can see here, data is coming from OLTP systems into the staging, and then it directly jumped into the data marts. You know, you don't have a big storage or something like that. There could be some smaller storage tables in between. There's no question we will have some intermediate tables and everything. Don't expect the data directly goes from here into the data marts directly. There could be some intermediate tables. I'm not showing in the picture, but you will have some intermediate tables. Okay, so data coming from data staging, the staging area will directly go to data marts, and this is the line that is showing here is nothing but a transform the conform diamond. That means they're going to share some of the aspects from here to here, here to here. Okay, you're kind of sharing some of the objects. So again, you know, these are the architecture types. Simply, you know, just want to give you different types of architecture that you might come across when you design in the data warehouse architectures. Okay, again, this point that you're seeing here are same thing that we talked before, but I just want to show in a pictorial way, and then your textbook that if you read through, you will find some of these topics that we're talking today. Okay. So next to the point is the characteristics of a data warehouse and a business intelligence. What are the different characteristics that we have? You know, it's a very high profile and a high impact. I talked about it already, because when I say high profile, that means even some organizations, even CIO and CFO and VP level people, they will be getting the reports out of data warehouse on a daily basis. They will be getting some of the flash you know, charts, the different alerts from a data warehouse directly onto their mobile devices. So it's a very highly high profile. That means the high profile people will be looking at your data. So I want to make sure the data is always consistent. clear. There's no questions about any data elements that you have in the data warehouse. There's no question about any calculations. So it is very important. So very high risk. Again, like I said, we talked about high risk is, you know, you've got to be very, clear on your design, making sure you're meeting the needs of the business. There's always a risk because it is not a cheap product to build because, as I said, as we already seen just by looking at some of these architectures, you already might be thinking, what are the things that are going to be involved? In the next couple of slides we're going to see. So you have OLTP system people working, supporting you. You have people who are working to extract and load and all that. You have people who are managing this whole database aspects of it. You have people who are managing the design of this whole design. You have people who are managing this, creating reports and all those things. So there's a lot of groups of people that are working in your organization to support your data warehouse. So there's a lot of cost associated with all of these things. Sometimes you don't have all the resources within the organization. You need to reach out to the other organizations to help, consulting companies and things like that. So all of those things will add cost to your data warehouse build. So it is a very high risk if you are not going to provide the results that business is expecting. So highly political. Okay, very good example I just gave a few minutes ago. A director coming to you and complaining, this data warehouse is nothing. I don't want this data warehouse. It is taking too much time. And every time I come, you're giving some excuse. This table is not there, this index is not there. I don't care about what you're doing. Give me the performance. Okay, so then you express the same frustrations on your team. So it's going to be political. You got to play sometimes politics. You got to be very, what I would say, come up with some reasonable explanations so that the people will understand. Because sometimes there is no technical solution that is going to meet someone's request to bring down a query's performance that is taking 5 minutes to 2 minutes. There is no way you can do it. That that because of the way that it is designed, because of the volume of data, there's a lot of other things. So it is going to be very political. So you need to be managing that in a meaningful way. Otherwise, you will be in trouble. I've seen many people getting fired and things like that. So it is a challenging task, but it is rewarding. It is you feel really happy when you achieve something in this field because you are in a challenging environment. Requires sophisticated, complex data gathering. Like as again said, it's going to be not easy. I think some of you already asked a question. When you're replicating, it's going to take space. A replication of data from OLTP, the third normal form in data warehouse, don't think it is simple, just drag and drop. You got to build all these extraction programs, all those interfaces and everything. It's just a complex process. Intensive user access training and support. This is another important aspect we're going to cover. Okay, so whatever you build, you need to have a strong support from the users, and you also need to educate your users in such a way that they understand your technology. So let us say you buy a BI tool. Make sure you invest time training the users. Make sure they understand. If they don't understand how to use your tool, then whatever you build, it is of no use. Okay, so it is a very important aspect. So we're going to cover this point in detail. High maintenance. Okay, maintenance aspects, every day is a challenge for you. So it's a very highly maintenance product. So you have to focus, even though there is no issues, keep looking at what could be potential issues. Okay, keep looking at database monitoring tools, work with the DBAs, get alerts. Okay, so what is my performance happening? Is there a query performance? Okay, today we are running a query that is taking 2 minutes. And in the last 2 years, it only ran for 30 minutes. So even though it took 2 minutes, you need to go back and look at why it is taking 2 minutes suddenly, where it ran only 30 seconds the last 2 years. So those kind of things, you have to keep looking at monitoring of your database results, and then come up with some solutions. Otherwise, suddenly it will give you a lot of problems for you. Okay, so it is some of the high level points. I put it here so that at least you understand. The next slide here talks about life cycle principles. Focus on the business is a very important thing. I don't want to mix things. Business process is a very important thing. I always tell, okay, if I'm building a data mart for a sales organization, don't mix some other things like banking information into sales. Don't mix credit information into sales. Don't mix claim information to sales, because as long as they're not related business units within your organization, don't mix them. As long as you build two different data marts, and on top of it, you can build another view on those two if there are some people who would like to access the data. So try to be as focused as possible to the business process. Build an information infrastructure. Again, that's the way we are going to build. We're going to see. Again, deliver into 6 to 12 month time frames. Don't take too long. 6 months is more realistic. Try to give something to the user so that they start practicing, and then as you build something else, so it's kind of an iterative, agile methodology, so that's more meaningful for you. Deliver the entire solution, query, display tools in addition to the database. Okay, so this is a key thing. Don't just deliver the data warehouse and say, you go and build your own reports, you go and do your own reports. So always think of giving a full solution, complete solution, in such a way that you build a data warehouse. Along with that, you give at least some level of reports. Okay, work with the business, give some sample reports, give some ad hoc reports, give some reports of the database, data warehouse that you build, and then on top of it, they can go and build their own reports afterwards. But at least I want you to think of some reporting on the day one, so that users have reports available by clicking the mouse. Okay, so keep that in mind, and then it should be good. So this is the data warehouse lifecycle aspect that I was touching before. As you can see here in this slide, we're going to touch all the aspects that we're going to cover in the next couple of slides here. This is a architecture diagram or life cycle diagram I picked from our textbook too. Kimball clearly explained the 3-tier architecture. I think last semester one of my students explained the same thing from another textbook, the 3-tier architecture, similar thing. Like I said, different authors will have different views. Kimball has put together this in such a way that you have requirements here. You have a top layer, where we talk about the products that are going to be involved, making sure all these products can talk to each other. They're compatible to each other. Like the BI tool that you're going to buy, like a Cognos or Business Objects, or then you're going to take what database we're going to have is Oracle, Sybase, SQL Server, whatever it is, and then what source systems we have, what kind of ETL tools we're going to use. So all those tools, we are going to talk product selection, technology basically here. Okay, the technical architecture. The middle layer is basically the design of your data warehouse. So dimensional modeling, the designing. Physical design, which is we talk about second half of the semester here, talk about physical nature, performance. What is the best way to partition the data? All of those concepts are covered here. ETL, extraction, transformation, load. So what are the designs that are going to have interfaces, everything? You need to make sure properly design those interfaces. Then the third layer is the BI, business intelligence. That is reporting and analytics. Okay, so you have architecture layer here, you have design layer here, you have front end, the BI layer here. Okay, then you deploy and then you maintain. This is a cycle here. Okay, so anyway, we're going to touch this in detail as we go, but I want to give you a very high level picture. And again, as soon as you see this picture, I know now you're thinking, okay, this is not an easy task. It will take time. You have people here, you have people here, you have people here, and this is a different technology. This might be a different technology. This might be a different technology. You want to bring everything together, make them work together, and all these people have to work collaboratively. And on top of it, you have business users coming, and you need to address those concerns. So it is going to be, you're adding more complexity as we go, but at least you will see the importance of this. Okay. So different project roles. I just put a slide here just for your awareness. There are a lot of job opportunities in this space. You have a business sponsor, which is very high level. You have a manager role for data warehouse. The project manager that manages the project. Business lead, so that is from the business side, who is going to be interfacing with the IT, who is running the project. Business analyst, data modeler, system architect, and then database administrators and all of those things, all those people. So it's just, there's a lot of job opportunities within this space. So again, these are specialized roles I am starting here. Data warehouse, DBA. I'm sure some of you in this class also might be database administrators, but I would say, database administration for an OLTP applications compared to a database administration for a data warehouse is slightly different. So we look at things differently. I would like to have a parallelism in my database design. I would like to have as much as pipelining possible in my execution styles. So I would like to use some of the parameters that support this. So the DBA in my space, I would like to have that kind of experience. Okay, so I've seen some of the DBAs that work really great in the traditional OLTP applications. When we bring them onto the data warehouse, they still think in the same line. Sometimes it's not going to work for me. So we want some data warehouse DBA that really knows how to tune your database so that it will perform better for the users. OLTP designers, again the OLAP designers. These are basically BI tool designers. So in terms of reporting, the cube design, and all of those things. ETL developers, BI management tools, application developers. So again, these are some of the special roles, and these are the standard project roles. So as you can see here, there's a lot of people working to make this product work. So it is going to be a challenging task to make everybody work together and deliver a product that's going to work for the business. Okay. So the next slide is data warehouse infrastructure. Before we go there, let me break the video here. It's already 34 minutes. Okay, so data warehouse infrastructure. Again, some of the points here we're going to cover in depth as we go into the second half of this course. But I just want to give you a very high level here. We want to make sure in the infrastructure side, performance drain and the operating environment. So we want to focus more on this. One of the issues we'll have in the operating system, in the operating OLTP side and also data warehouse side, and technical skills that are required, operational issues such as funding requirements and all that. The SOP standards. This is another important aspect I will tell. The SOP standards is nothing but your guidelines, the programming guidelines, design guidelines, and organizational requirements. Okay, when you're buying a product, you can't just let it go and buy a product from a shelf and install, because if it is your own laptop, you can do, but you're working for an organization, so you need to make sure you're buying a product that meets your organization standards. So sometimes when you want to go and buy a BI tool, if it doesn't fit your organization architectural needs, you can't buy it. So make sure you're working with your organization architects. Make sure whenever you're buying a product, because there are a lot of products you're going to buy, database products, BI products, ETL products, all of those products that you're going to buy for your data warehouse, make sure you review them with your architecture leads, and then make sure they agree that these tools are compatible and you can buy them before you try to implement in your landscape for your data warehouse. Okay, so what are the platforms you'll have in infrastructure? You have source systems. We talked about staging area, which is the entry point to your data warehouse, the app server, application server, desktop tools. So what is application server? So sometimes when you design your infrastructure, you have ETL server, you have application server, which will be running all the user interactions and everything, and you might have a database server, which is mainly used for database activities. You see here, you have ETL server, you have app server for application server, that is applications are running, users are directly interacting with that, and you have a database server where you have all the data is there. So again, why do you want to create these different servers for these different tasks? Can we just build everything in one? Yes, you can build everything in one. No, nobody's going to say no. But when you're building a very large data warehouse for entire organization, having users in Europe, users in Latin America, users in North America, users in APAC, and then people are coming from different network, different bandwidth. Just now we have seen some of you had problem with the voice. You can't listen into me, and some people could able to listen very well just with the WebEx technology that we are seeing here. So we have only 100 users here, and if I have an organization with 60,000 people, and you don't know how many people are coming and what bandwidth and everything. So you got to be very careful. Make sure you're going to give an architecture in such a way that you never have bottlenecks, you never have issues. So if you have a database server that has its own capacity in processing and everything, that means you're not contending, you're not competing with the same resources when a user is trying to run the report. So user reports are running an app server, application server, which has its own processing power, it has its own RAM, and all those things. But it goes to the database server, get the data, present to the user. So you see this, you can build everything in one server, all of those things, and then deliver the results. Or you can build different servers, interact with each other, and then deliver the results. Again, it all depends on what you're going to do. I'm just giving some of the high-level views how you might end up building. So this is another view here. You could have a data warehouses infrastructure varying from 500 gigabytes to 250 terabytes. In my experience, I have only seen a data warehouse that has a 500 gigabytes. I have one data warehouse which is 1 terabyte, and I have one other database which is connected to SAP, which is around 3 to 5 terabytes. So that's all I have seen. So there are very big data warehouses that in the marketplace, but I'm just giving you a very high level here in this slide here again. Just giving you a picture, what we're dealing with here. Nature of use of this data warehouse infrastructure. So in the database server, you're just trying to do some ad hoc queries for the power users. There will be users running from whatever they think in that moment. They build a query and run it. There will be some standardized queries that will be run regularly every day, every week, every month, and produce the results and send it to the users. And data mining, which is again trying to do analyzing, deep dive into the data, try to get some results out of it. So it's also possible here. Technical support needed here is you have a hardware, operating system, and database engine will all require specialized support. So you need to have technical people that understand what kind of hardware you have, what kind of operating system you have. Is it a Unix operating system, Linux operating system, Windows? We have used all three. So we had one data warehouse on Linux infrastructure, we had one data warehouse on Unix, and we have built one on a Windows architecture too. So it doesn't matter which architecture I have, but we just use what you are available. Okay, everyone works great. Software requirements also very important for your data warehouse design. So again, the point that I'm trying to say in this lecture here is we talked about architecture, we talked about some of the design aspects, very high level view, and we're also giving some of the concepts about what kind of roles we have, what kind of architecture design we have, and what are the different things that you could think of. I think some of you already asked. I saw a table of 1.5 terabytes in eBay. I don't know, funny, that's good, excellent. I'm happy to see the 1.5 terabyte table, one table. That's a very good experience, I would put it. I have never seen that. It's a good experience that you have. I'm very happy to know that. But anyway, the point that I'm trying to say here in this lecture here is trying to give you a picture, at least very high level picture, so that you understand, what we're dealing with here. Things are not easy. And when I say 1 year, some of you said, oh, that is too long. Why it is taking 2 years to build? So now you understand the complexity. Okay, so these are the different operating systems we already touched. Mainframes you'll have to deal with, Unix systems, NT servers, so very common. We'll touch again. You might have symmetric multi-processing application servers, massively parallel processing application servers. So we have one application server that has 6 multi-threads, multi-processors within there. So it's just an architecture that you work with and then build something that is going to meet your needs. Okay, so for the performance aspects, I think some of you first question, we're going to touch all these aspects as part of second half of this course. Indexing is in depth, we're going to study that. Physical organization, how the data is stored, which tables, which partitions, which disk locations. We need to understand all those things so that you plan out so that they can improve performance. Caching and blocking is another thing that we're going to touch. Data distribution, how you're going to distribute the data so that you get optimal results. How much memory you need. Chip architecture, which is the CPUs and everything. How many processors you need for application. How many processors you need for database. All those things, we're going to be very carefully look at those aspects as we get into the second half of this course. Okay, but I want to give you a picture of what we are going to get in. So database engine, again, relationalism mostly we're going to try to study in this course. Multidimensional is another aspect that we're going to cover in this course, which is multidimensional is one of the things that we talked about, the cubes. the cube analysis and everything that we're going to study here. So we're going to enhance the concepts as we go. We have introduced in the first 3 lectures here, what is the data warehouse, what is the data mart, who are the big gurus in this field, what are different types of architectures. So we're slowly building our knowledge base in the data warehouse space here, okay? So, so we're going to study these things. Mostly we're talking about relational databases for your underlying database, and then we talk about multidimensional databases for reporting purposes, analytics purposes, okay? We're going to study on that. What are the different front room that is in the from the user's perspective? Client server architectures, your web architecture where users come in from the web, and also you have some desktop tools that you will install on the local laptops or desktops for the users so that they can use those tools for the reporting. And there will be some supplemental tools for reporting purposes. Okay, so again, these are the front room. That means for the end user perspective, how they're going to interface. So there could be some desktop tools on their laptops, desktops. There could be some client-server applications running, and there could be web application where users can come through the web portal, dealer portal, things like that, portal environment. And then there will be some supplemental tools that also will be available for reporting purposes. Okay. Again, these points we're going to study in detail as we go. The load window is a very important aspect for me. In terms of how long we have to load the data, because always remember, this is an interesting and challenging task for data warehouse, because the amount of time you have from the business close end of the day, like let us say in North America, we have 3 different time zones. We have the Eastern time zone, Central time zone, and West Coast. So if I have an application running here, I want to make sure what is my least amount of time when I can start. What is the latest time I can start my extracts? If I start at 8 o'clock in the evening, which is still 5 o'clock in the West Coast, okay? So I need to be planned out clearly and when I need to start extracting. Let us say the safest bet in most of my situations is 9 o'clock in the night, because that is 6 o'clock. Most of the time business will leave by 6. So if I start at 9 o'clock, and what time business users are going to come in to work again in the morning, 6 o'clock, 7 o'clock, or 8 o'clock. So let us say 8 o'clock they come into the business. So that means I have from 9 till 8 o'clock in the morning, I have 11-hour window. I need to finish all my extracts, loading, processing, everything, and make the data available for the users. So it is, you think 11 hours is too long, but you will see very fast once we start understanding the concepts. You will be struggling to find 10-minute window in that 11 hours to tweak some other job in between. So it is that complicated in order to design your schedule to fit that load window. And backups is another task. Even though we say it's a very large database, terabytes of data, you still will have backups, and we still have daily backups. You still have weekly backups. Everything standard way that you always have for any operational system. User support. You always have to have change management is also part of it. So these are the topics that, is all part of your operational management. So you have to deal with these things as you're building data warehouse. Okay. I think that is the last slide of the class for this presentation that we have today. Interestingly, we have covered all the slides exactly 1 minute past the hour. The 9:30 here for me in the morning, I think, which is 9 o'clock for you. I will stop the lecture right here, but I will take up the questions like I did in the past, so that those of you who have plans, you want to drop off, you can drop off at this point. I'm going to stop my video also, and then we'll start the video again and take up some questions. Thank you again for everyone for joining today's lecture. We'll see you tomorrow. Okay, it's recording now. Okay, good. Okay, so here, Jenish is telling here as you have shown, bottom-up approach. So we should have one top table data mart, or we can have design with only data marts available. Now again, you could start with, if you have data marts already there, you don't have to redesign everything. You can build on top of it. So don't try to scrap everything and build something, because at the end of the day, you arrive at the same one. So I would enhance what you have building other data marts or bring additional data into that. Okay. Venkatesh, in Kimball approach, what if the query is dependent? Dependent OM, I don't know, Venkatesh, I think you need to repeat the question there. I can't clearly understand the question. Madhava, I do not have data warehouse background, maybe a simple question. Do users directly query on big tables or do they contact data warehouse IT team to get ad hoc reports? Very good question, Madhava. As you have seen some of these slides here, let me go back to the slide. Okay, so let us say there is a very big table, 500 gigabyte table here, or like one of your friends said here, 1.0 terabyte size table here. And when you're writing the queries, we don't normally give access to that table to the user because it's kind of flat table. I would like to give the access to the users at the data mart level where data is already kind of summarized, where it's kind of aggregated or it is more denormalized, and it is available in a multi-dimensional format, something like that, and then users are going to access the data at that point. Okay, so to your question, do I give access to the users to directly write the queries? If I say, if I'm working with you, Madhava, and you are my business user, and I know you know the business knowledge, I know you have a database experience, and I know you can write some queries in Access, or you know to manage this. If I have that confidence, I don't have a problem giving you the access to run the reports directly from that table. But if I have a user that don't know anything about database, he doesn't have any knowledge how the tables are linked, how the keys are working and everything, zero knowledge, then I will never give access here. This access is completely not given. No matter what, I will not give the access. Even if you get the recommendation from CIO, I will say, sorry, this access is completely forbidden for the users that don't have any knowledge. Because this is a 1.5 terabytes or 500 gigabyte table, and if I give access, there could be situations they might run some reports, they might run some queries that could crash the whole database, because you could try to extract everything out of it with a simple query, and when you try to run an open-ended query like that, you try to extract everything onto your desktop, you are going to burn all the network, you're going to burn all the CPU resources, then nobody else will get to do anything. So it is the comfort level that you have, based on how you're interacting with the business, what is the business knowledge that you have, based on that you make the decisions. And I have an example I can give you. So when I took the data warehouse, I think in 2005, I was managing data warehousing in my organization for 5-6 years, from 2005 to 2010, I think, or 2009, 2004, 2009 or something like that. So I was lead for a data warehouse manager, and then after that I moved on to SAP and all that. It's a different story. But when I was doing it, when I picked some of the data warehouses from a different manager, and that manager, he has never given any database level access to even a single user in his domain. Okay, he was very strict. He said no database level access for you, period. So any reporting that you need, you have to access through this link, and then that's the only way you can do, and then the tools will directly point to that. There is no direct access. So as soon as I came, I felt really bad because I know the users, they have knowledge, they've been asking this manager for a long time, I need access, I need access. He had his own problem, or he had his own thoughts that if I give this access to these people, there could be a problem. I am 100% with him. There is no question about it. You got to be very careful when you make those kind of decisions. You're risking yourself. But you have to, in this environment, you got to take some calculated risk and move forward to gain the confidence of your business users. As soon as I came into this managing this data warehouses, I looked at it. When I was talking to them, I was surprised. I asked the users, why nobody has asked for database access in this? They were shocked at me and said, oh, we've been asking for this a long time and it is never given. So then I started engaging in discussions. So look, there is a reason why we don't give the database level access because of these issues. But if I have a confidence that give me a couple of names from your organizations and give me the confidence that you can write your own Excel access queries, you can build your own access queries, you understand database concepts, because access is a common thing that is in the business field. So if you have that, I don't have a problem giving an access to you, my database, but to limited set of people. But I'm also cautioning you, if something happens, if I find that you're causing a bottleneck, you're causing an issue, your access will be terminated that minute, period. So with this kind of understanding, we managed to give the access. So to answer your question, Madhava, again, it's not easy question. So do the users directly query the database in big tables with this explanation? Yes. A few minutes ago, no. Okay, so I hope you got my point. It's just a situation, the way you manage the situation and you grant access to the need as the need arises. Okay, so hope you got my point there, Mr. Madhava there. If you still have any questions, go ahead ask the question later. Venkatesh, okay, so sorry, I think you're extending your question from the previous one. Let me see. So is Kimball approach, what if a query is dependent on data marts? Yeah, I think two different data marts. That is what I said. You know, if you have a data mart here, you have a data mart here, and there are some users that want to get some data out of this, some data out of this. Yes, we have tools today, the BI tools, the business intelligence tools, like a Cognos, business objects. All these tools, they are so enhanced today. I mean, like their technology is so advanced in such a way that they don't have a dependency that they can only connect to one data mart. They can connect to this and pull data out of this, present to the user in a reporting format that is going to be needed for that manager, for that user, something like that. So again, so I don't recommend building other data mart on top of this because there are some users who wanted to give the data. Come up with the intelligent solution. Let us say, okay, you have a BI tool that can source from both the data marts, the data sources. You can go to this and this, get the data, present to the user. So these are the things that I want you to start building, start thinking. As soon as somebody says, oh, I have a sales data here, I have some other data here, but I want to get both data in my reports, don't start thinking, oh, you need a data mart that has both the data. That is the solution, but that is not an optimal solution for me. Okay, so I'm not telling that is not a solution, that is not the right design. So that is one of the designs, one of the ways of addressing the issue. But for me, which is the best way of addressing the issue is go to this, get the data, whatever you need, because this is already data mart, this is already in the denormalized view, this is already denormalized view, and then bring them whatever fields you need, and then put them in a BI tool, and then give the results to the user. So that is, that is more logical. Again, if there are a lot of users, okay, let us say I have 100 users here and 300 users here. Okay, in this data mart, I have 100 users using this data mart and 300 users using this data mart. Now I have almost 150 users combining these two data marts, or 200 users combining these two data marts. Now they are asking too much data. Some of the objects from here, some of the objects from here. They're just combining all of these things. There's too much user group. Then I would lean towards, okay, good. Look, there's a lot of user interaction here. They want this, and there's some here, and in order to avoid the performance, because you're again marrying the data from one data mart to other data mart. It is going to take time. Just like I said in OLTP, it joins. So we're trying to do the same thing here. So in that case, I will change my thought. Now I'm going to come back with a solution saying, probably I need to come back with you for a new approach where I would build something physically out there available and put all the data in one place and then run the reports on top of it. Okay, so Venkatesh, I hope you got my answer there. It's just again a choice. Situation is going to dictate what you're going to deliver. for your question there. We discussed on various data warehouse designs with diagrams. I just want to know, where do big data systems sit in these systems? Bibin, I think it's a good question. So there is an article I posted on big data. So just go through that and we can take this question afterwards, okay? Rajeshwari, okay, I'll come back to you on that. Can you drop an email to me, Rajeshwari, okay? So we can take up that question for you. Arnab, I saw 1.5 terabyte on eBay. Arnab, you caught my attention right there. I couldn't resist. Wait, my thought. I immediately jumped on to your point. Very happy to know that there are tables like that. There are users that are using. Just not me. That some people might be thinking what PC is joking here. There's a table of 500 gigabytes. Is he crazy? That's good. Now Arnab is joining the crazy group here. 1.5 terabyte database table. Excellent. So now you can, if you have seen that, Arnab, and try to poke in a little bit more. Try to see what kind of architecturally they have implemented some of the indexing and some of the partitioning things they have. Try to poke, if you don't know, talk to some DBAs, somebody, just, casually chat, and if you get some answers, post on the Texilla so that it will benefit other people, okay? Again, you're asking very general, so you don't have to be specific targeting this, it's very general, so I don't think it will be any proprietary information. So very generic, just pose it. Okay, in case of this, this could be a possible solution, partition by this, partition by that, or indexes, is the bitmap indexes are better, whatever you find, discussing with your colleagues or discussing with somebody in that organization, please share. Don't give a specific about organization, specific about details, anything like that. It doesn't matter for anybody here. It's a proprietary for organizations. I will be very careful. But any generic information you would like to share, I really appreciate, Arnab, and I'm sure it will help the discussions for this class, and it just enrich the material that we are having this course. Okay, that's good. Thank you, Arnab. Again, excellent point. And again, some of you who are in this class, I know they have different experiences. That is what I like about this course. I have people from all over India coming to this class with wide experience, with a lot of business background. Please share your experiences. That will benefit our discussions. Okay, good. So let's go. With the software nowadays getting supported on cloud, do we not have batch window of even hours now? Okay, I mean, Ambarish, yes, you're right. I think like I said, it's a challenging environment. It's not easy. I'm telling you, it is. That's why I said it's a common sense. Most of the times, you need to sit back and relax and come up with a solution that is going to meet. Sometimes it might not fit. Just an example I said, for Venkatesh, okay, what am I going to do when I have to get the data from both data marts? And the answer is a BI tool first place, and requirements change. You have too many people looking at the same data, then you have to think differently. Okay, yes, using a BI tool work for you, there's no question. But as you have more people would like to get to the same data, then the BI tool might not be an option. So you have to change yourself and get along with the situation and come up with a different solution. So that is part of data warehouse. I think that is where the challenging lies, and I'm sure that's where the beauty of this whole environment, because you're dealing with a wide range of user groups, complex infrastructures, and too much data to deal with. It adds up everything to the complexity and less window to process everything. You see how the beauty here. Okay. Anyway, that's good. What happens if we skip the staging area in process of data warehouse? Harshit, very good question. And I'm sure a lot of people thought about it. And I've seen some data warehouse designed in such a way that some people skipped some interfaces directly moving. Let us say I have 100 interfaces coming from a source system into the data warehouse. 100 different data objects are extracted from a source system and moved into data warehouse. So these are 100 different interfaces where you have extract, transformation, and load. So out of those 100 interfaces, let us say I have 80 interfaces going through this flow, and like you, Harshit, somebody thought, okay, these 20 interfaces, they're trivial, very simple. Why should I waste storage? Why should I waste time? Why don't I directly move? Oh, what a great idea. That's good. You did achieve, you're not you're not affecting the performance. There's no question about it. You're basically saving some time because you're avoiding one stage here because you need to insert here and then extract and load here. So you're saving some time. There's no question. You're saving some storage. There's no question. You're seeing all these benefits when you made the decision to take those 20 interfaces outside the staging. But you're not forgetting one simple thing. When you're talking about 100 interfaces, you have 100 tables here, you might have 50 tables here, you might have 50 tables here. This whole data warehouse, at the end of the day, you might have 1,000 tables altogether. I'm just throwing some number here. And you would be again thinking, are you sure 1,000 tables? Yes, I have seen a data warehouse, more than 1,000 tables. Okay, so when I have these many tables, this much things going different dimension, different areas, and I need to have some process built into it. And I need to follow some process, some standards, some documentation process. So if I have, just because I'm saving probably 1 gig or 2 gig space, okay, to save that, probably 10 minutes of time saving, I put these 20 interfaces outside this loop. So immediately, that means that it's going to be a main headache for a maintenance aspect. I will give you a simple scenario here. When I design my data warehouse, I have used some naming convention. For all the interfaces that are coming, all the staging will come with some naming convention. All the these things will come in a different naming convention. We're going to touch these things elaboratively the second half. Because you asked the question, I'm elaborating now here. So I'm using this. So now all of a sudden you have changed your concept. So now I have 20 of them bypassing this. What naming convention I have to use? So I'm introducing another naming convention. So it's just, life is easy for me if I follow a simple process because I have too many tables to deal with, too much data to deal with. These small things like this, just to save trivial processing time, trivial space, bypassing these standards. I'm sure you can convince your manager, but if you come to me, I'm not convinced because for me, implementing is one thing, maintenance is another thing. When it comes to maintenance, okay, I'm not talking about maintaining the data warehouse in 1 year. I'm talking about maintaining long term. So like I said, I built a data warehouse in 2001. Even today it is maintained, and the people who are using the data warehouse, the maintenance team, they're so comfortable because we have followed a standard. Just by looking at one process, they can easily tell. By looking at the script, they can tell. It is a script that is connecting a source to the data warehouse table, staging area. And this is a script that connects from here to here. And this is a table. As soon as I see the table name, I know it's a staging table. Just by looking at the table name, I know it is a data warehouse table. Just by looking at the table name, I can tell it's a data mart table. So these are the standards. Maintainability, maintenance is important for me. So Harshit, your point is right. You're right on the track. You can skip this data warehouse staging area. For some cases, you can convince the management, you can convince the team, but looking at the long range benefits, looking at the maintenance aspect of it, I would not recommend doing it. Hope you got my point there. So if you have further questions, ask me down. Okay, good. That's a good question. What are the relational databases you saw are mostly used for data warehousing? I don't know. I think most of the data warehouse tables that we have used, again, our organization, again, it depends because, again, you look at this. In organizations, they don't want to buy different relational database tools. If I start with an Oracle, pretty much I was trying to live with an Oracle. Okay, so it's depending on organization. So I would say in my experience, because again, all my experiences in this company, I've been here for 16 years. So I worked on relational databases like Oracle, Sybase, DB2, and then SQL Server. So those are the main four data warehouse the relational databases that I have used for data warehouses that we had. Chetan, is there anything called Spread Mart? What is that? First time I'm hearing that word, spread mart. Please share some other additional details on that. So it's going to help me understand that, Chetan. I've not heard about that. I'm serious. In our software, if this doesn't finishes in 1 hour, an hour, we forcefully terminate it. Excellent operation. That's a good way to manage it. If it doesn't work, just kill it. Okay, I'm just joking. But anyway, again, it's a thought. Very good point that you're making there. So it's interesting to know. Abhitesh Das, do you get a chance to see that post in Texila for sample DB for data warehouse? I don't think so. It's going to be complex. I have last semester I have asked one of my student group to build a simple SQL Server database and try to implement some of the database concepts there. But they have sent me that, I can pass on to you, but it's not going to be meaningful for you because there's a lot of scripts they've written. Unless until they explain to you, it's not an easy thing to understand. I'm sorry to say, but it's not, like I said, it's a complex thing. You need to spend a lot of time to understand a data warehouse concept. So even though you have a simple data warehouse like that, I would not post it because it's going to confuse you than giving an input to you. Okay, so I don't have anything. I'm not planning on doing anything like that. Sunil, the big data appliances are not relational. Do they follow bottom up or top down? Um, Again, Sunil, for me, it doesn't matter because I would, in case of big data, so personally, I would, like I said, my preference nowadays leaning more towards bottom up. Top down approach is too risky, and also given situations like economic conditions and given the tendency of the people, the business users, it's everybody wants quick results. They don't want to wait too long. Okay, so I think bottom up is the right approach. Kimball approach, what if the query is dependent on two? Okay, we talked about that. Okay, we talked about that. Kimball agreement or the okay, so we will go one frame. So here we are having conference related to cloud computing and big data, which is also including data warehousing. I'm asked to create an abstract on a related topic. Which topic should I write on, and what should be written in abstract? Just send an email to me, Manpreet, so I'll give you more details. So we'll elaborate there. Okay. I don't have any idea what should be written in abstract. Okay, like I said, send an email to me, so we'll take up that one. Our load window handled when the business or kind of 24 hours, like let's say for airline shopping websites, and you don't have time. Michael, that's a good point. It is challenging. You got to address the challenge. We'll take up those points as we go for sure. I think the only way that I would say in those situations is when you have a 24-hour type of applications, there is no easy way to find a window to load. Not only that, if you have a global regions, that adds complexity. You have business users working in Europe, business users working in North America with a 7-hour difference. There's no right time when is a good time to load the data into your data warehouse. So in case of 24-hour applications, it's more challenging. So what do we do in that example situation like what you've given? I would work with the business and clearly understand the pattern. What is the database volume in the operational side? When is the window that has a lower volume of operations? I'm sure, even though it's a 24-hour operations, there will be some time where compared to other times, you have some lower activity on the database level. So you need to find that window and probably say cutoff time. So this is the logical window that I would pick because the number of database intensive operations are less compared to other times, and this is the window I'm going to use. And then in that window, you can clearly say this is a cutoff time. If let us say it is 8 o'clock in the evening, say 8 o'clock is cutoff time, and then you are going to extract the data from that point and load everything into the data warehouse, and then again the next evening 8 o'clock you start the same thing. So it's just anything that posted after 8 o'clock, even though you're doing extracts, you're cutting off at 8 o'clock. So you don't touch any data that is posted after 8 p.m. if you decide that is your cutoff time. Okay, so you need to be very clear on these points. Like I said, these things look trivial, but these are the important points. And you need to communicate this clearly to your business, making sure I'm cutting off at 8 o'clock, and that is my cutoff time. And any transaction that posted even a second after 8 o'clock, it will not be available in your report next day. If a transaction is posted past 8 o'clock, it will be available not tomorrow. It will be available in the day after tomorrow's reporting. You need to be very clear on that. So I would recommend that. So I hope that will help you, Michael. We have defined as a power users to each data mart and gave the access. That's good, Suresh. I think, like I said, I agree with you 100%. And I've seen even today. I'm telling you, Suresh. I have seen some managers in Europe. We have a data warehouse. They resist so much. They don't want to give any access to the data marts. Period. So again, you can't fight with them. They have their own argument. I agree with them because there is a risk. If they come to me and ask PC, what are they even going to tell me if the database crash? This is a global database, and I have to answer to the management, and then I have to back out. So it is the comfort level you have. It is the risk that you would like to take, and then move forward. So I agree with this 100%. There is no risk of giving access to the data mart level to a limited set of users. That is the key point for me. Don't give this access to everybody. Limited set of people is okay to have the access. If a user fires a select query on a 500 gigabyte table, it may take 100% CPU and may run for more than 2 days. Arnab, you are 100% correct. That is the reason why we don't want to give direct access to the data warehouse tables. So it is a challenge. So we have to address those challenges in this environment. Okay, that's good. Avinash Kunshu. With the ODS have the same table plan schemas as the source data, or it is tailored based on the reporting. I mean, will the data from 2 tables of source data to be put into one table in ODS? Yes, Avinash, you're right. Again, when it comes to ODS or DSO, the tables are merged. Some of the tables, it's not going to be exactly like what you see in OLTP. Whatever you're building in this space here, in this area here, this is all tailored towards your reporting needs. You're not building something just because you see something in OLTP. Anything that you bring into the data warehouse, you're bringing in purely based on the need of your business users, reporting needs, and analytics needs. Okay, that's a very clear point you made, and I agree with you 100%. Big data analytics, analytical appliance, do they follow Kimball or Inman? Also, are they relational? Sunil, this is, I think you tried to ask this question before, probably I skipped this. I don't have any example to give to that point. Again, like I said, the big data, these days, like for example, Hadoop, they don't use, they have their own database concepts and all that. So again, the technology these days is completely different. So, you might have to research some more on that area. But, when it comes to data warehouse, like I said before, I don't have a preference on Kimball or Inman. You can use either one based on the needs, but both will give the same results, like I said. I also want you to think in the same direction. I don't want you to bias with any one of those things, one of those areas. Okay. Vinayak is asking, shouldn't we have maintenance window for data warehouse, like for implementing change, OS patches, hot fixes as part of operational phase? Yes, Vinayak, you're talking true. We need to have that. There's no question about it. And we're going to talk all these points in the second half of this course. Okay, so we'll touch all these points. So we'll take up all these points. I agree with you 100%. There will be a maintenance window. Typically on my data warehouses, we have clearly defined a maintenance window from I think Sunday morning, 4 o'clock in the morning till 11 o'clock in the morning. That's a maintenance window where we have no data warehouse activity going on, purely infrastructure type of activities, OS patches, hot fixes, whatever it is you have, database reorganization, all that. Okay, backups, all those archiving, whatever you call it, all those things will come in there. So maintenance window, and we do that every Sunday from 7 o'clock, sorry, 2 o'clock in the morning till 11 o'clock. Again, why we pick that, it's just an optimal window for us. So that's not the right way. So to look at it, you just pick what is the best for your current situation. We have an employee database in Sybase, 10 gig. We have configured another server with a server, Microsoft Server, SQL Server, periodically migrating the relevant tables and given access rights for users to view reports which are developed using PHP. Can I say that server database is a data warehouse? Yes. At a very high level, you can call that as a data warehouse because it is. You're not updating that SQL Server database. You're just only refreshing that with your main Sybase database, and then you're only having reports on top of this SQL Server. So it is considered as a data warehouse. Okay. What happens if we skip the staging area? We talked about this, Harshit. Hope we got it clear there. Okay, I don't know why you asked the question again. I hope that I try to give a very good example there. So put it in a different format. I think it's the same question was raised because I had to skip that. We are only talking about RDBMS. How can we use NoSQL DBS like MongoDB in data warehouse? Anshu Mishra. So you need to teach me that. I'm serious. I'm not using this MongoDB. I have heard about this MongoDB and there's another database like Shaquila DB. Somebody was telling. I'm sorry, I've not seen myself, so I can't answer your question. So probably you can teach me some of the tricks there. Okay. Similarly, I'm maintaining a transaction table of 9 terabytes using a multi-cluster database called Aster. It gives a lot of performance experience. Nagavaibhav, excellent, 9 terabyte table. Man, this is interesting now. You're making me interesting and challenging. It's good to know these points, Nagavaibhav. Share some of the points. What you do in those situations. What are your performance experiences? How you address them. Please post some of those experiences on Taxila and have others read them and comment on those things. Okay. Take some fun. Spend some time on that. Help your colleagues and help your friends here. We now shipped with 5 terabytes of RAM. Yes, you're right. The technology has grown really tremendously. I agree with you 100%. Things are changing drastically, and it's not the same thing as like it was 10 years ago. We have passed a lot of hurdles, and now we are in a comfortable zone, and a lot of things you can do with this. That's why I'm telling you some of the things that our textbook taught, our textbooks taught, not only our textbook. You can take any data warehouse textbook, some of the authors, some of these books are really old, and the concepts, they're still thinking in that level. We need to, talk today's terminology. It's just reality is reality. So the concepts are same. That's why we still like those textbooks. The author's concepts, views are strong, but some of the points they give might be out of date. So that's why we need to be realistic, more, take these examples. And again, I'm sorry, Swapnil, if you see this message again, I'm not trying to intimidate you or trying to stop you, whatever. Everybody has whatever you type. Feel free to type the question there. When you said, let's take the questions at the end, I felt I don't like that, so I'm sorry. That's how I am. I would like to take the questions as they arise. And so anyway, just took me that question again. So if you see this video again, don't take it personal. It's just again a discussion that we have in this class here. Uh, generic reporting tools are failing to query such amounts. How would a BI solution scale in such cases? Naga Vaibhav, yes. See in BI, see in case of data warehouse BI tools, what we try to do also is we are going to tailor the data needs to the business user needs. And then we're going to build some aggregate tables, and all those aggregation table builds and everything will fall in the batch window. We try to squeeze that in the batch window so that tables are built readily available. So now even though you have 1.5 terabyte table, so based on the business needs, when they're trying to query, you talk to them on what kind of data you need, what kind of aggregation you need. So based on that requirement, you put together a script and build an aggregate table, and you build that offline. Not when the users are running the queries, and make it available. So when a user comes, they just query this smaller table with aggregated table, which is actually built on top of this 1.5 terabyte table. So you're not giving direct access to that. You're building in between something, meeting the user needs, and you're done. Again, you have to remember one simple point. Don't think that these users will need all the data that is available on that 1.5 terabyte table at a given time. So they don't need all of it at one time. So I'm sure they need pieces of it in different times. So based on that concept, you need to work with the business, try to understand the requirement, build something that's going to meet it. Okay? Hope that helps answer your question there. Data staging area, Vitesh, we're going to cover more details in ETL, so don't worry, you wait on that question. So Ishwar, excellent point. No, I'm happy to hear these comments. I said I have seen a data warehouse with 1,000 tables or plus 1,000 plus tables. I have an answer here. Ishwar is telling we have seen a data mart with 1,300 tables, 1,300. Hey man, that's excellent. I like it. So at least somebody is supporting my thoughts, my ideas, that what I have exposed, and it's just good, So that's the way to go. It's good. Data virtualization, where we can maintain one golden copy of data and directly use it for analysis or reporting instead of loading the data staging area. There are a lot of other advantages of ETL, the staging area. We'll touch all those things in ETL concepts. I've given one or two examples, but we're going to deep dive on that. Don't worry. Just keep that discussion for now. We'll come back when we have ETL, okay? For sure, we have time. All the data warehouse maintained before ETL tools existed. We built our own ETL tool in 2001 for my data warehouse. We have developed in-house developed ETL programs. I'm going to show you some of the ETL programs when we are doing ETL. So hold on to the topic too, Naga Vaibhav, so we will see that. Okay. So yeah, there are some in-house. It's not difficult. It's very straightforward, simple, procedural. So it's not a difficult thing. So we have built ETL tools ourselves. So that's also another reason why it takes more than a year. Big data analytical appliances. Do they follow Kimball? Samuel, you're not going to leave me here. Okay, so let's go. AdventureWorks data warehouse is a simple data warehouse database available. Okay, that's good. Good to know that others. Like I said, there's a lot of things. The technology improved a lot. There's a lot of things out there, a lot of tools. So there's a lot of scope. ODI is an easier tool to develop data warehouse. Okay, Sunil, that might be, I'm not exposed, so please share your email ID. Yes, it's probably should be there in my handout. If not, I'm going to post my email address. It's not a problem. So you can also link to LinkedIn. I'm in LinkedIn, so it's not a problem. I know for a business, it will refresh data continuously for every 15 minutes or 24-hour operation. Yeah, Ishwar, that's interesting. Let me share my email address before I forget, so you can see this. So for businesses, if it refreshes data continuously for every 15 minutes for 24-hour operation, yeah, that's a challenge. I'm sure, I know a lot of people would like to do that, but as you know, data warehouse processing is not a 15-minute thing. It will take at least 2-3 hours. So don't recommend that. We have tried to do that, but it's a very challenging and at times it's very risky too. So you're adding more complexity, more performance issues yourself. So try to avoid real-time updates to data warehouse, but I know there's a lot of people push for that. So Rajeshwari, load window for online business. If we have data marts for each region, then we can identify load window for each data mart. Is my understanding correct? Yes, you're 100% right. If you have different business units with different regions and users are different, and yeah, you could have different window and then clearly define what is your cutoff and then work accordingly and communicate clearly so that everybody on the same page. There's no question for you, so it will be easy for you. Okay, Nagawai, okay, good, good, good. We're done. My daughter is sitting next to me here, so she's asking, when are we done? So we'll be here. We'll be done. So can we create a report which has the totals and subtotals based on layout table, star schema table? Yeah, I think Anurag, we're going to touch on this in the BI, so don't worry about it. Okay, we'll have time. The report needs 5 columns from a data mart and the other 2 columns. Should we break the data mart into 2 smaller data marts? Abhitesh, we'll deep dive on this again. Don't make that quick decision like that. It's not that easy. And I want you to think a little bit more and come with a logical explanation. So we'll touch all those points. Okay, good. That was the last question there. Again, thank you very much. Very nice questions. Hope you got some of the answers that I was trying to explain clearly. And feel free to email me. There is an email address right there. And let's stay in touch. Okay. Again, be active and share some of your thoughts on these big database tables, the experiences, and share that on the Textella forum. Okay. Also, read my article that I posted on big data, and then give your comments. Thank you and good night. See you tomorrow. Netherlands architecture types, oven smoke, oak, model. Do you only have a plan on your class, or do you have a